Our universe is vast and unique, and with each day that goes by, humankind keeps moving a step further in discovering the world around us. Since the inception of space technologies like the James Webb Space Telescope, invented by the US National Aeronautics and Space Administration (NASA), the exploration of space has become so much easier. The James Webb Space Telescope has proved itself to be a miraculous invention and has transformed the perspectives of cosmologists and the way they view the solar system and all of its entirety. Invented mainly to watch and analyze astronomical objects in space through infrared radiation, this magnificent invention is currently the largest optical telescope in space. Its brilliant infrared resolution technology and high sensitivity enable it to view objects from as far as the center of the Milky Way galaxy. Coincidentally, while exploring the contents of the Milky Way galaxy, the JWST made a shocking discovery of a massive structure that has left scientists in awe. What is this huge structure? How will it change cosmological study as we know it? And what are the next steps scientists will take about its discovery? Join us as we explore the huge structure discovered by the James Webb Space Telescope at the center of the Milky Way galaxy. Formerly known as the Next Generation Space Telescope, the James Webb Space Telescope is one of NASA's greatest inventions. The multi-billion-dollar telescope was renamed in September 2002 after James E. Webb, the administrator of NASA from 1961 to 1968, during the Mercury, Apollo, and Gemini programs. The Space Telescope's design was also led by and developed by two main agencies, the Canadian Space Agency (CSA) and the European Space Agency (ESA), and the unique roles they played in the development and operation of the James Webb technology. Launched on December 25, 2021 on an Ariane 5 rocket provided by the European Space Agency, the James Webb Space Telescope took off from Europe's spaceport in French Guiana on the northeastern coast of South America into space. The prime contractor on the $10 billion project was Northrop Grumman. At the same time, the NASA Goddard Space Flight Center (GSFC) in Maryland directed the telescope development, and the Space Telescope Science Institute in Baltimore, on the Homewood campus of Johns Hopkins University, oversees the operation of the powerful space telescope. This large infrared telescope has a primary mirror comprising an 18-hexagonal mirror segment, manufactured from gold-plated beryllium that further creates a 6.5-meter diameter mirror compared to Hubble's 2.4-meter telescope. This empowers the James Webb Space Telescope with a light-collecting area of about 25 square meters, a whopping 6 times difference from the Hubble telescope. And when compared to the Hubble, it can be seen that the James Webb Space Telescope observes in a lower frequency range, from long-wavelength visible red light through mid-infrared 0.6 to 28.3 micrometers, unlike the Hubble that operates and observes in the near-ultraviolet and visible 0.1 to 0.8 micrometers. And it means that the James Webb Space Telescope needs to be kept in an extremely cold condition to keep functioning, a temperature between -223 degrees Celsius, -370 degrees Fahrenheit, so that the infrared light that comes from the telescope does not get in the way of the collected light. This magnificent invention is deployed in a solar orbit close to the Sun-Earth L2 Lagrange point, about 1.5 million kilometers, 930,000 miles from Earth, where its 5-layer sun shield guards it from warming by the Earth, Moon, and Sun. Earlier this year, on January 8, 2022, the team assigned to the Webb mission fully deployed the telescope's 21-foot, gold-coated primary mirror, completing the last stage of all major spacecraft deployments for the Space Telescope to begin science operations successfully. The successful completion of all the Webb Space Telescope's deployments is historic, said Gregory L. Robinson, Program Director of the Webb program at NASA headquarters. This is the first time a NASA-led mission has ever attempted to complete a complex sequence to unfold an observatory in space, a remarkable feat from our team, NASA, and the world. A couple of weeks later, on January 24, 2022, the mission team took a great leap by firing Webb's thrusters and inserted the Space Telescope into orbit around the Sun at the second Lagrange point, its final destination, a large distance of nearly 1 million miles from planet Earth. "Webb, welcome home," said Bill Nelson, NASA's administrator. "Congratulations to the team for all their hard work ensuring Webb's safe arrival at L2 today. We're one step closer to uncovering the mysteries of the universe, and I can't wait to see Webb's first new views for the universe this summer." The location of the James Webb Space Telescope gives it a perfect and wide view of the cosmos, and at the same time allows the telescope's scientific instruments and optics to remain in a state that would be cold enough for this glorious invention to function and perform standard science like it's built to do. This space technology also broke a record on its first mission, as the United States President Joe Biden viewed the first full-color image from the Webb for the first time, the sharpest and deepest infrared image of the distant universe ever to be taken. As it is called, the Space Telescope's first deep field, the image shows galaxy cluster SMACS 0723, a cluster teeming with thousands of galaxies and having the farthest and faintest objects ever to be observed in the infrared. The following day, on July 12, 2022, more images taken by Webb's state-of-the-art scientific instruments were released so as to show the telescope's prowess. They are the Southern Ring Nebula, WASP 96b spectrum, Stephan's Quintet, and the Carina Nebula. In recent findings, a new cosmic creation story has come alive. Thousands of never-seen-before young stars were spotted in a stellar nursery, namely 30 Doradus, and were captured by the perfect equipment just for the job, NASA's James Webb Space Telescope. An alias, the Tarantula Nebula, called these young stars. This is due to the appearance of its dusty filaments in the previous telescope images, as the nebula has been a favorite for a very long time when studying star formation. The James Webb Space Telescope further revealed distant background galaxies, including the elaborate composition and structure of the nebula's gas and dust to back up the young stars. The Tarantula Nebula is the brightest and largest star-forming region in the local group, the galaxies that are close to our Milky Way. It is 161,000 light-years away in the Large Magellanic Cloud Galaxy. It serves as home to the most massive and hottest stars known. Due to this, astronomers focused 3 of the James Webb Space Telescope's high-resolution infrared instruments on the Tarantula. When viewed with the Space Telescope's near-infrared camera, the region looks like a burrowing tarantula's home lined up with its silk. When you check the near-cam image, you will see that the nebula's cavity is being cut out by the intense radiation from a cluster of massive young stars that shines in pale blue as seen in the image. Only the concentrated surrounding areas of the nebula are able to resist erosions caused by the stellar winds from these stars, thereby forming pillars that appear to face the cluster. There are forming protostars in these pillars which will in turn come out from their dusty cocoons and take their turns shaping the nebula. As Webb Space Telescope was orbiting and observing in space, it observed a very young star doing that exact process, even though the near-spec depicted that the star was just starting to surface from its pillar and it still maintained a cloud of dust around itself alongside. This process of a star formation in action would not have been revealed if not for Webb's high-resolution spectra at infrared wavelengths. Suppose the region is viewed in the longer infrared wavelengths whenever it is detected by the Space Telescope's mid-infrared instrument, the dust glow, cooler gas, and hot stars. In that case, the region takes on a completely different appearance. Among the stellar nursery clouds, points of light indicate embedded protostars when gaining mass. When shorter wavelengths of light are either absorbed or scattered by dust grains in the nebula, this causes Webb not to be detected, as longer mid-infrared wavelengths get access into the dust and finally revealing a previously unseen cosmic environment. One of the major reasons why the Tarantula Nebula is a center of attraction to astronomers is that the nebula possesses a related type of chemical material. This chemical material is the same as the massive star-forming regions observed at the universe's cosmic moon when the cosmos was just some billion years old. The formulation of stars was at its peak. Star-forming regions in our Milky Way galaxy are not producing stars at the alarming rate as the Tarantula Nebula does, and do not have the same chemical composition. This uniqueness makes the Tarantula Nebula a perfect example of what is happening in the universe as it approaches its brilliant high noon. The Webb Space Telescope would give astronomers the perfect opportunity to watch and compare observations of the star formulation in the Tarantula Nebula through the use of the telescope's in-depth observations of far galaxies from the actual period of cosmic noon. The James Webb Space Telescope has already started to unravel the universe in a way that has not been seen before. The brilliant invention is just beginning its mission to redefine the story and history of stellar creation. Even with the several efforts made by humanity and the long amount of time spent on stargazing, the process of star formulation still stands to keep a lot of mysteries unknown. This is due to the inability of humans to get crisp and sharp images of all that has been happening behind the very thick cloud of stellar nurseries. But as the biggest optical telescope in the universe, it is obvious that the James Webb Space Telescope is here to give us a show. All we have to do is sit back, relax and learn as it unlocks the many mysteries of the universe. Let's hear your thoughts about it in the comments section below.